Jen has one fair four-sided red die and one four-sided blue die. The red die has sides numbered 1, 2, 3, 4. So red die is numbered 1, 2, 3, 4. And the blue die has sides numbered 1, 3, 5, 7. Blue die is 1, 3, 5, 7. The discrete random variable R represents a score from one roll of the red die. The discrete random variable B represents a score from one roll of the blue die. Write down the name of the distribution of R. So R, if we consider here, let's take small r. The outcomes that we get from the red die is 1, 2, 3, 4. And it's mentioned that it is a fair four-sided red die. Fair four-sided red die means the probability of red here will be 1 by 4 for each of these outcomes since it is a fair die. Now, we have studied that if the outcomes having the probability values the same, if all the probability values are the same, then we say that the distribution is discrete normal distribution. Discrete normal distribution. The reason is that all the probabilities are having the same value. It's just because it's a fair four-sided red die. Probability of getting a 1 is 1 by 4, 2, 3, 4. Probability of any of these outcome is 1 by 4. It's just the same. In this case, we say that it is a normal distribution. It is a discrete normal uniform distribution, you can say. Discrete normal uniform distribution. Now, moving on to the B part here. For the B part, probability of a red less than 3. So, red, the possible outcomes are 1, 2, 3, 4. And probability of red, we know it is 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So, probability of red less than 3 means it can be either 1 or 2. Probability of getting 1 is 1 by 4, or probability of 2 is again 1 by 4. Less than 3 means it can be either 1 or 2. So 1 by 4 plus 1 by 4 is 2 by 4, which can be further simplified as 1 by 2. So that is the answer for the B part, which is 1 by 2. Now, for the C part, we need write down the value of E of R. So E of R expected value, the formula is what? Sigma R into P of R is equals to R. Now, we have R and we have P of R is equals to R as well. So what we need to do here is we just have to find out R into P of R is equals to R. So this is P of R is equals to R, uniform distribution function. So probability distribution function is there, and then the outcomes are also there. So let me just multiply this R into P of R is equals to R. So 1 into 1 by 4 is 1 by 4. 2 into 1 by 4 is 2 by 4. 3 into 1 by 4 is 3 by 4. And 4 into 1 by 4 is 4 by 4. So expected value of R means sigma, summation of all these values, R into P of R is equal to R. So that is 1 by 4 plus 2 by 4 plus 3 by 4 plus 4 by 4. I did not simplify this 4 by 4 and 2 by 4. The reason is that if we have all the denominators the same, you can just add the numerators. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. 10 divided by 4 is 5 by 2, which is 2.5. 2.5 will be the value for E of R. That was the first subdivision of C. Second subdivision of the C part is E of B, or expected value of B. So for expected value of B, we need the outcome of B. What are the outcomes? That is 1, 3, 5, and 7. 1, 3, 5, 7. Now in this case, probability of getting blue, 1 in blue, will be, since it's again it is a fair four-sided blue die, so probability of B is equal to B will be, since it is a fair die, each of them have the same probability. That is 1 out of 4 for each of them. Now, we need E of B. So same like the first part, E of B, the formula will be sigma B into P of B is equals to B. So what we can do is, we can just make one more column here for B into P of B into P of B is equals to B. So that is 1 into 1 by 4 is 1 by 4. 3 into 1 by 4 is 3 by 4. 5 into 1 by 4 is 5 by 4. And 7 into 1 by 4 is 7 by 4. And we know the formula for E of B is equal to sigma B into P of B is equals to B. That means we just have to add all these values. Sigma means summation of all these values. 1 by 4 plus 3 by 4 plus 5 by 4 plus 7 by 4. The denominators are the same, just add the numerators. 7 plus 5 is 12, 12 plus 3 is 15, 15 plus 1 is 16. 16 divided by 4 is 4. So that was the second subdivision from the C part. Now let's move on to the next subdivision here. That is showing your working, find variance of B. So to find variance of B, we know the formula for variance of B is E into E of B square minus E of B. So E of B we already got from the previous subdivision. E of B was 4. We got this value as 4. We need to find out E of B square. So B was 1357. 1357. That spinner was having the outcomes as 1357. If B is 1357, B square will be 1, 9, 25, and 49. And then probability distribution function will not change. It will be the same. That is 1 by 4 for each of them. Now, first let's find out E of B square. Expected value of B square will be sigma B square into probability distribution function. So this will be, let's first find out B square into probability of B is equals to B. What will that be? B square into 1 by 4, that is 1 by 4. And 9 into 1 by 4, that will be 9 by 4. 25 into 1 by 4, that will be 25 by 4. And 49 into 1 by 4 will be 49 by 4. So E of B square means sigma B square into, so B square into P of B is this row, we just have to add all of them. So 1 by 4 plus 9 by 4 plus 25 by 4 plus 49 by 4. So add all the numerators. 9 plus 1 is 10. 10 plus 49 plus 1 is 50. 50 plus 25 is 75. 75 plus 9 is 84. So 84 over 4, which we can simplify it to get 21. Substitute it in the formula variance of b, that is e of b square minus e of b the whole square, the expected value. This we got it as 21 minus e of b. In the previous subdivision, we got the value as 4. So e of b the whole square will be 4 square. So 21 minus 16, which is 5. That will be the value for variance of b. So variance of b, you just have to substitute in the formula over there. Let's move on to the next subdivision here. Jen rolls each die once. Find the probability of r plus b is less than or equal to 5. So here it is addition of red and blue. So now red, we know it was 1, 2, 3, 4. So let's take 1, 2, 3, 4. And then blue was 1, 3, 5, 7. 1, 3, 5, 7. So R plus B means we need to add both red and blue. So this is red and this is blue here. So 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3, 4. 1 plus 4, 5. 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. 3 plus 4, 7. 5 plus 1, 6. 5 plus 2, 7. 5 plus 3, 8. 5 plus 4, 9. 7 plus 1, 8. 7 plus 2, 9. 7 plus 3, 10. 7 plus 4, 11. And we need the probability of R plus B less than or equal to 5. Altogether, you can see that we have 16 possible outcomes, out of which how many of them are getting less than or equal to 5? Satisfies the condition, these 3 less than or equal to 5. So 5 also we have to consider. I think only these are the possible outcomes here. 1, 2, 3, 4, 5, 6. All the remaining numbers are greater than 5. So this will be probability of R plus B less than or equal to 5 will be 6 out of 16, which can be further simplified as 3 out of 8. Now this was the E part. Now for F, probability of R square less than B. So F, we have to find out what R square is. We have to find out what B is. So R square, for R we know it is 1, 2, 3, 4. Red was 1, 2, 3, 4. So R square will be 1, 4, 9 and 16. B we know it is 1, 3, 5, 7. 1, 3, 5 and 7. What we need to find out here is probability of R square less than B. Now, R square is 1, 4, 9, 16 and B is 1, 3, 5, 7. So, what are the numbers that we have? R square and B. So, R square is 1, B is 1. R square is 4, B is 1. R square, this is for R square and this is for B. So R square is 9, B is 1. R square is 16, B is 1. We are drawing the sample space here. R square is 1 and B is 3. R square 4, B 3. Now 9, 3, 16, 3, 1, 5, 4, 5, 9, 5, 16, 5, 1, 7, 4, 7, 9, 7, 16, 7. So I can see that there are altogether 16 possible outcomes here, out of which how many times we got R square values less than B. So this is not This is also cannot. R square is greater than B, 4 comma 1. R square is 4, B is 1. So that doesn't satisfy the condition. R square is not less than B. R square is not less than B here as well. R square is less than B in this case. R square is not less than B, not less than B. R square is less than B. R square is less than B here as well. And 9, 5 R square is greater than B. 16, 5 R square is greater than B. 1, 7 R square is less than B. 4, 7 R square is less than B. So altogether we have 1, 2, 3, 4, 5. 9, 7 and 16, 7 R square is greater than B. So we have out of 16, 5 of them. So probability of R square less than B is 5 out of 16. We used sample space to find both of these. Part E and part F, we have to use sample space to get the final answer. Now moving on to the last part of this question. Now the random variable D is defined as the magnitude of the difference between the score on the red die and the score on the blue die. The table below shows the cumulative distribution function. D is given, f of D is given. So what we can do is we can find out what probability of D. Cumulative frequency is given, but we can find out the probability distribution of this. So P of D is what we need to find out. The final question is find the value of this P. So this will be 1 by 8. Now this will be 3 by 8 minus 1 by 8. 3 by 8 minus 1 by 8 is 2 by 8. Now this will be 9 by 16 minus 3 by 9 by 16 minus 3 by 8. That is 8 into 2 is 16. 3 into 2 is 6. So this will be 9 minus 6, which is 3 over 16. So here this will be 3 over 16. To get this value over here, 3 by 4 minus 9 by 16. So 3 by 4 minus 9 by 16. So to make the denominators the same, multiply by 4. So this is what? 12. 3 times 4 is 12. 12 minus 9, that is again 3 over 16. Now this will be P minus, we don't know the value for P, that's what we need to find out. This is P minus 3 by 4. Here this will be 15 by 16 minus P. And the last one will be 1 minus 15 by 16. 1 minus 15 by 16. So this is what 1 means, it is 16 by 16. So to get the numerator, subtract 16 minus 15 is 1. So this will be 1 over 16. Now the random variable D is what? Magnitude of the difference between the scores on the red die and scores on the blue die. So we know red is what? Red is 1, 2, 3, 4. 1, 2, 3, 4. And blue is what? Blue is 1, 3, 5, 7. 1, 3, 5, 7. And now the difference between red and blue is what we need. Now 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 3 minus 1 is 2. 3 minus 2, 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 1, 4. 5 minus 2, 3. 5 minus 3, 2. 5 minus 4, 1. 7 minus 1, 6. 7 minus 2, 5. 7 minus 3, 4. And 7 minus 4, 3. So it's given that probability of 4 here. What is the probability of 4 here? So probability of getting 4 will be 1, 2. Only 2. So probability of getting 4 from this sample space, probability of getting 4 is 2 out of 16. 2 out of 16, or we can write it as 1 over 8. Now, from this table, probability of 4, we got it as P minus 3 by 4. Probability of getting 4 is P minus 3 by 4. So, comparing both, probability of 4 from the table is P minus 3 by 4. And probability of 4 from the sample space is 1 by 8. Therefore, P will be 1 by 8 plus 3 by 4. So to get the denominator, say multiply by 2. So this will be 1 by 8 plus 3 2s are 6, 6 by 8. That is 7 over 8 will be the value for P. So this was the first question from the Statistics Jan 2025 paper. If you have any doubt, feel free to write it in the comment box. Thank you for watching.